Good day, folks. Welcome to Bytes Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at question 6, which is now a parabola, a kind of question for the November 2024 paper. Okay. It says in the diagram below, the graph of f of x with a that equation and graph of g, a straight line are drawn. And then C of those coordinates is a point of intersection between the two graphs. EH is drawn parallel to the y-axis. So it means it's just a straight line. And a point F, and a point on F. Okay, let me go back. EH is drawn parallel to the y-axis with E, or a point on F, and H, a point on G. Beautiful. So I think we have everything here. So 6.1, calculate the coordinate of B, the turning point of F. Oh, beautiful. How can I do this? Remember, if you're doing grade 12, you know that at the turning point, the first derivative, it is equal to 0. And then it's going to be 2 multiplied by negative. It's going to be negative 2x plus 4. It is equal to 0. And then x will just be equal to 2. And then you just take your 2 to that equation. You substitute it. F of 2 here, you substitute it here, negative 2 into negative into 2 squared. Negative, it is outside, then 2 inside, then you square plus 8 plus 5, guys. And then you get something like beautiful, like 9. So the coordinates of B here, it is what? 2 and 9. If you are not familiar with this structure of a derivative, you know at the turning point that you can say x, it is equal to negative b divided by 2a, the normal grade 11 way. What is b? B, it is 4. 2, it is negative 1. And then you get x, it is equal to 2. And then you come back to this step. You substitute back to your equation. Still fine. Whichever process or a method you use is correct, guys. Correct. There is no faster way. It's still the same thing, by the way. And then show that the equation of a straight line, it is show that the equation of a straight line through AC, through A and C, it is given by 2x plus 2. So I need a gradient first for me to show the equation. I need a gradient of this one, and then I have any point. So I need a point here, the point of A. How can I get the coordinate of A? What is A? A, it is a point on the graph of F. So I can find the x-intercept, okay? So I can find the x-intercept of this one and say, okay, negative x squared plus 4x plus 5, it is equal to 0. And then let me divide by negative. Okay, and then I'm going to give factors of 5 such that when I subtract them, they give me that one. Yes. And then I'll have x, it is equal to negative 1, or x, it is equal to 1. And then I need, this is the x coordinate of A. This is the x coordinate, negative 1, it's here. And then this is 5. This is the coordinate of D here. So it means here it is 5. This one, it is negative 1, guys. But I need the value of y. So I'm going to say, the value of y, guys, is 0. So here it is 1, negative 1 and 0 for A. And then for D, it is 5 and 0. So now that I have the coordinate of A, I can find the gradient AC. Gradient AC is going to be the y coordinate of C minus the y coordinate of A divided by x coordinate of C minus x coordinate of A, which is, and I'm expecting a positive answer because it is a positive gradient. So it's going to be 8 minus 0. The coordinates here are negative 1 and 0. And then divide by 3 minus 1 minus 1, which is the same as 3 plus 1. And then I get the gradient of 2. So the gradient of AC, it is 2. Then I can say, therefore, y minus y1 is equal to m into x minus x1. Guys, this long thing for 3 marks, arch. Y minus, what is the coordinate on my point? I can use this one or I can use this one. I prefer using A. I think A is going to be easy. What is y1? Y1 it is 0. M it is 2x. It's going to be how much? X minus what is x1? It is -1. It's going to be +1. So it's just y. It is equal to 2x plus 2. Oh, guys, into kangaka for just 3 marks. But yeah, guys, you need to start first by finding the coordinate of A so that you can find the gradient. And then after finding the gradient, you use any of the points to get an equation of the straight line. So we have done that, guys. We have done that. So let's just remember here it is 5. This is -1. Okay. And then we move on to the next question. It says to us, calculate the maximum length EH for F is greater than G. the length EH, maximum length EH. So remember EH, it is on the graph of F, and then H, it is on the graph of G. Okay, so for us to calculate the maximum distance, maximum length, you can find the y coordinate here. I think it's also correct to say, okay, when y it is equal to 8, when y is equal to 8, how many values of x can you get? You're going to get 2 values of x here, and then one is going to be 3 and one is going to be whatever. I think it's 1. I don't know. But for you to make things seem easier, when they want the maximum length EH, just say f, graph of f minus graph of g, it is equal to 0. And then what is graph of f? It's going to be negative x squared plus 4x plus 5 minus 2x plus 2, it is equal to 0 again. And then when I do my mathematics thereof, it's going to be negative x squared plus 4x minus 2x, it is 2x, 5 minus 2, it is 3, equal to 0. And then this is just an equation, but I want what? The maximum length. So remember, every time in when you are doing grade 12, the word maximum makes you become dizzy. What do I mean? Because you're going to say, this is not equal to 0, guys. This is equal to the maximum length, the distance. Let me just say it is equal to EH. Sorry, guys, it is equal to EH. So I need to do what? This is just the equation of EH, but I need the maximum distance. So I'm going to take the derivative of EH. You can just say EH like that, guys. It's no case. The derivative of EH is what? It's going to be negative 2x plus 2. And then remember, for my derivative, I need to equate that to 0 to get a maximum again. So it's going to be negative 2x plus 2, it is equal to 0. X, it is equal to 1. Okay, when x it is equal to 1, then I go back to where EH it is now equal to what? EH, it will now become, I come back to this equation and say EH is going to be negative into 1 squared plus 2 into 1 plus 3, and then I get an answer to be 4 units. 4 units. Okay. What you can do again is that this is a axis of symmetry, right? So the points here are gonna be equal. So if that's the case, you can say, let me go to the graph of f and see where is my graph equal to 8. So I'm gonna say 8, it is equal to negative x squared plus 4x plus 5, and then take x squared to the other side, take 4x to the other side, and then 8 minus 5, it is plus 3, it is equal to 0. And then the factors thereof are x minus 3, x minus 1. Therefore, x it is equal to 1, or x it is equal to 3. I already have x is equal to 3 here. So it means this one, this is of C, this is of E of C. And then it means this one, the x coordinate here, it is 1 and what? And 8. But now, can you see if it is 1 there, it means it's going to be 1 all over the off. So it means here it's going to be 1 for all of them. So it means here the x coordinate it is 1. So let me find the x coordinate, the value of y on the graph of G if my x it is 1. Let me find y. How can I find y? I go to my equation there of this one. I say it's going to be y, it is going to be, let me say g of 1 is going to be 2 into 1 plus 2, which gives me 4. So it means here it is what? 4. Then for me to find the distance here from E to H, it is the vertical distance. So it's going to be top. Remember, vertical distance is going to be y top minus y bottom, which is 8 minus 4, which is now equal to what? 4 units. Still the same, guys. I think I'm ready to move on. I am ready to move on. And then I'm going to say now, okay. Where? Okay. I think I'm moving on to the interesting question. Yes. For 5 marks, determine, given k of x it is equal to f of x plus m with that equation sharp, determine the values of m such that g is a tangent to k. Okay, so k of x it is equal to blah 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 blah. So let me just draw a graph of k of x. The graph of k of x, it will be the same as the graph of f, just that it will have just some few shift there. So it's gonna be like this. Okay, it's gonna be like this. This is the graph of k, and then I want g to become a tangent. I want g to become a tangent at this point. So now, if I'm having a graph, a function, and a tangent, what are the properties at the point of contact? At this point where they meet, they share x and y coordinate. So they share a coordinate there. But not only do they share a coordinate, the first thing that you should take note that they share what? They share x and y. Okay, let me say a share common point. They have a common point. And another thing again is that the gradient of the tangent, it is equal to the gradient of the function at that specific point, at that specific x coordinate where they meet. So not just f of x, or in this case it is k, not just on k of x, but where x it is equal to whatever point that they meet there. So where x it is equal to the point of contact, whatever the x value where they meet thereof. So let me try to answer the question. It says determine the value of m such that g is a tangent to k. So remember, if it is a tangent, it means now the gradient of a tangent will be equal to the gradient of the what? Of my my function. So, and I do not know the x coordinate where they meet, the specific x coordinate where they meet. Okay, so I'll just say I know that the gradient of my function, it is equal to, remember the gradient of a function, it is the derivative. It is equal to the gradient of a tangent. Remember tangent, it is my what? G, which has an equation like this. And remember, if I were to derive this, the gradient will be 2. So, but since well it is in the format of mx plus c, m, it is this one, 2. So, what is now the derivative of kx? I can derive this whole part. I can derive it, I get what? Negative 2x minus, then when I derive this, 2mx, I'm deriving with respect to x, so it does the same as having negative 4x. You just take out, when you derive this, it will just be negative 4. Similarly, it will just be negative 2m. M squared is just a constant. Again, we are not deriving with respect to m, we are deriving with respect to x. So m will be just a constant, plus 4x will be just be, which will be 4. It will just be 4. 4m is just a constant, 5 is just a constant. It is equal to, what is the equation of a tangent? Rather, gradient of the tangent, it is 2. Let me find the x coordinate where they meet. How can I find the x coordinate where they meet? I will solve for x. So it's going to be negative 2x. It is equal to 4 minus this one is going to be negative 2m minus 2. And then this 2m is going to be positive on the other side. And when I solve for x, x is going to be divided by 2 by 2. It's going to be m minus 2. So they meet at this point. Remember, I drew my graph here. Let me repeat that. And then my tangent somewhere here. So I now know the point where they meet. It is when x it is equal to m minus 2, and then y it remains unknown again. But now what you should take note of is that the m here, the y here that you get, it is the same for both graphs. So it means I will say, okay, let me find, I know they will share the same point. So I will say, okay, it means k of k of m minus 2. Okay, it is equal to g of m minus 2. Why am I saying that? I am saying when x is equal to m minus 2, they have the same what? They have the same value of y at this point where they share the very same x. It means if x is equal to m minus 2, the y is the same for them. So it means y of k when m is equal to minus 2 is the same as y of g when x is equal to m minus 2. So I can say, oh, okay, if that's the case, what is k into m minus 2? I can come back here to this formula and substitute what is m minus 2. I substitute x as m minus 2. Okay, so it's gonna be crest. It's gonna be negative into m minus 2 squared minus 2m into m minus 2 minus m squared plus 4 into x minus 2 plus 4m plus 5. Guys, do you allow me to erase this? I think you have already seen it. Or let me just do this. I'll write it underneath here. First condition of that, the gradient at specific x coordinate. Which specific x coordinate? M minus 2 in this case. So I'm going to look at the second condition that says the value of y at this x coordinate, they are common, they are the same. So common y value at x, it is equal to m minus 2. And then let me try to substitute. Remember, I said it is negative into m minus 2 squared plus what? Or minus 2m x, and then minus m squared plus 4x, which is 4 into m minus 2 plus 4m minus 2, I think, or plus 5, equal to what? G of m. G of m, it means when I see x, 2 is going to be m minus 2 plus 2. And then let's do mathematics. It's going to be minus, this is m squared, negative m squared. M times negative 2 times this is going to be plus 4m plus 4 minus 2m squared plus, I'll just do mathematics, minus m squared plus 4m minus 8 plus 4m plus 5 is equal to 2m minus 4 plus 2. Let's see which one cancels off. Negative m squared let me see. Negative m squared minus 2m squared. Was it minus, guys? Minus 2m squared. Okay. 4m plus 4m. I don't see here. What's that now? Okay. So let me just collect, guys, what I have. Negative, okay, let me do this. Negative m squared minus 2m squared minus m squared. And then 4m plus 4m plus 4m plus 4m. I'll just subtract minus 2m. And then the constants that I'm left with, 4, negative 8 minus 4 plus 2 plus 5. So, okay, okay. And guys, this one here is not m minus 2. It's m minus 1. Oh, I'll have to repeat the process again. M minus 1 here. It's m minus 1, guys. Mudimo. So I'll have to go back and say m minus 1 minus 1 minus 1 is not minus 2. So let me repeat the process again. Sorry, it's m minus 1, not minus 2. So if I do that again, it's going to be negative into m squared minus. Remember, you can do this slow, guys. But now I can already see this. It's going to be m multiplied by m squared, I can multiply by the negative, and then m multiplied by negative 1 multiplied by 2 plus this is going to be plus 2m minus, it's going to be minus 1 minus 2m squared plus 2m minus m squared plus 4m minus 4 plus 4m plus 5 is equal to 2m minus 2 plus 2. And then this one cancels off already. This one cancels off already. Let me check things that cancel off. It is this 2 and then negative m squared. Okay, I have this. I have this. These are the m squareds. I did not say they cancel. I'm just collecting the m's. And then the constants are there. Are going to be just left like that. Okay. Guys, I don't know why I continuously make mistake. This was supposed, I think sometimes being fast does not help. So it's supposed to be x is equal to negative m divide plus 1. Yo, Mutimo. Which is 1 minus m, the same as 1 minus m. I'm sorry, guys. I'm sorry. 1 minus m here. 1 minus m there. 1 minus m. Mutimo. Okay. So let's repeat the process. Negative 1 plus 2m minus m squared minus 2m plus 2m squared minus m squared plus 4 minus 4m plus 4m plus 5 is equal to 2 minus 2m plus 2. Okay. 2m, negative 2m. Okay, plus 2m minus 2m, they cancel. And then negative 4m and 4m, they cancel. And then I'm just left negative 2n like that. Okay. And then negative m squared minus m squared, it is negative 2m squared plus 2m squared, they cancel. And then I'll be left with what? So basically, I'll be left with negative 1 plus 4, which is 3. 3 plus 5, it is 8. And then on this side, it means I'll be left with 8. It is equal to 2 plus 2. It's 4 minus 2m. So 4, it is equal to negative 2m. M, it is equal to negative 2. Guys, this thing, it wants you to be careful. But yeah, m, it is equal to negative 2, guys. M, it is equal to negative 2. Negative 2. So yeah, guys, sorry for the silly mistake, but yeah, I think the analogy is the same. If you, with these two things, every time when they talk about a tangent and a specific, a tangent and a function, these two things will always help you. You will see also on question 8, those last question were of a tangent, they also follow the same analogy. So thank you guys for joining me. Hopefully you enjoyed. And again, sorry for the errors that I did, the off. But yeah, it's good, guys. Bye.